we present watercolor printing, a technique to print physical prototypes with the main characteristics of watercolor using a photograph as input. Our prints combine fine details and subtle color gradients and exhibit delicate patterns created by water. We achieve reproducibility by printing with woodblocks. In woodblock printing, the negative of a single color image is carved on a flat wood surface. Ink is applied on it before it is pressed on a paper. The woodblocks are designed by our image processing pipeline and carved by a laser cutter. A photograph with the desired theme is given as input. We use a color palette extraction algorithm based on k-means to output the color map. The color map assigns pixels to a set of watercolor paints with the same size and appearance as the color palette. A multi-class image segmentation algorithm based on a probabilistic graphical model maps the pixels to a set of user-proposed semantic classes and outputs the semantic map. Next, a defocus estimation algorithm outputs the smoothness map. The darker the color value, the sharper the photograph is on that pixel. We combine the semantic map, the smoothness map, and the designer-given threshold to get the water map image. White and black represent areas that watercolors and dry colors are applied respectively. The user selects the area of interest. First, we print the masking fluid, a rubber material that controls the water application. For the design of the masking fluid woodblock, we combine the dry color area, edges extracted by the gun edge detector, and the user selection of the area to print. We use an aerosol spray to dampen the paper following the same sequence of sprayings and absorptions for all of our results. Next, we print the watercolors. For the design of the watercolor woodblocks, we expand every color of the watercolor area, taking into account the masking fluid area and the details. This step creates overlapping blocks, one for every color, which allows to design smooth gradients between them. To fabricate the shading blocks, we proposed a novel approach that identifies and expands local extreme on an image. Please look the paper for details. The local minima define a woodblock with a darker shade of color, while the local maxima are areas that we subtract from the watercolor woodblocks. The local minima and maxima create the shading. Finally, we print the dry colors and the details. To design the dry color woodblocks, we intersect the color map with the dry color area. And to design the detailed woodblocks, we extract finer minima and combine them with edges of the dry color area. The last spray facilitates the colors to diffuse. Please look into the supplemental material for details of our choices on the fabrication pipeline. Here you see prints with different colors or printed differently. The interpretation of these results is up to the designer's aesthetics. We selected heterogeneous photographs to see if our pipeline generalizes well. A portrait highlights the importance of shading on the 3D geometry of the face. The flower shows the smoothness of the color diffusion between two different colors, and the bird further extends it to more than two. In contrast to previous results, this image has more detailed texture on the dry color area. Thank you for your attention.